The first question deals with finding function values on the unit circle. So to begin, let's actually go through that and let's look at the unit circle, because it's nice to be able to use the unit circle, but it's also important to understand where the values on the unit circle come from. So on the unit circle is a circle with a radius 1 centered at the origin. So if we're here at 0 degrees and 0 radians, we're to the right 1, up none. At 90 degrees or pi over 2, we're not over any, but we're up 1. Here we're at negative 1, 0. Here we are at 0, negative 1. And each of these ordered pairs help us know trig values at each of these locations. If sine of a given angle is y over r, and the radius here is 1, then when the radius is 1, sine is just the y coordinate. So on the unit circle, the y coordinate tells us sine of that particular direction. Cosine is x over r, but if the radius is 1, then that simplifies to x. So the x coordinate at a given point tells us cosine of that direction. Tangent is still y over x. Notice tangent is not dependent upon r, just y and x. And the other trig function, the other three trig function values are just the reciprocal of these. Cosecant is the reciprocal of sine, so 1 over y. Secant is the reciprocal of cosine, so 1 over x. Cotangent is the reciprocal of tangent, so x over r. So if we know a point on the unit circle, we can determine the trig functions for that particular direction. So in each quadrant, we have 3 special points. We have 4 quadrantal angles, 0 degrees or 0 radians, 90 or pi over 2, 180 or pi, or here's 270 or 3 pi's over 2. But we discussed in a previous section that 30 degrees is pi over 6, 60 is 2 30s, which would be 2 pi's over 6, which reduces. This would be 3 30s, 4 30s, so 4 pi's over 6, 5 30s, so 5 pi's over 6, 6 pi's over 6, 7 pi's over 6, 8 pi's over 6, 9 pi's over 6, 10 pi over 6, 11 pi over 6, and then we'll be back to where we started, which is 2 pi. 45 degrees is pi over 4, so this is 1 pi over 4, 2, 3 pi's over 4, 4 pi over 4, 5 pi over 4, 6, 7 pi over 4, and then 8 pi over 4, or 2 pi. So those are the radian angles at each of these directions on the unit circle. But we also want to know the ordered pair for each of these. So eventually we use the ordered pair to determine the trig value, but the ordered pair comes from the trig values. Keep in mind this direction is pi over 6 or 30 degrees. If we go back to a 30, 60, 90 triangle, 30, 60, 90 triangle, our sides are 1, 2, and the square root of 3. Well, if the x-coordinate is cosine, cosine of 30 is adjacent over hypotenuse, so root 3 over 2. The y-coordinate is sine, so sine of 30 is opposite over hypotenuse, or 1/2. So at 30 degrees, cosine is root 3 over 2, sine is 1/2. If we go to 60 degrees, from 60 degrees, cosine is 1 over 2, and sine is opposite, opposite over hypotenuse, so root 3 over 2. If we looked at a 45, 45, 90 triangle, our sides are 1, 1, and root 2. Cosine is adjacent over hypotenuse, 1 over root 2, which simplifies to root 2 over 2. Sine is opposite over hypotenuse, which simplifies to the same thing. Every other point is just a reflection of that. This point is a reflection of this one. So this point is to the left, root 3 over 2, up 1/2. This one is to the left, root 2 over 2, up root 2 over 2. This one is to the left, 1/2, up root 3 over 2. And we could do that for all of the points. The one that's the farthest to the right is over root 3 over 2, either positive or if it's to the left, negative. The one that's down the farthest, excuse me, the y value is negative root 3 over 2. The one that's down the least, the y value is negative 1/2. If the one that's over the least, the x value is 1/2, or if it's to the left, it's negative 1/2. Oops. And the ones in the middle are the root 2 over 2. So root 2 over 2 minus root 2 over 2, and both signs are negative here. So once we use our 30, 60, 90 triangle, 45, 45, 90 triangle to get the points in the first quadrant, all the other ones are just reflections. And then we can use these definitions to get sine, cosine, and tangent, secant, cosecant, cotangent of any direction that's one of our standard angles. So one really important thing to know is how to get the unit circle. If you're just given a piece of paper and something to write with, can you draw the unit circle and fill in all of the values? If you know that the ratios are 1/2, root 2 over 2, root 3 over 2, then they have to make sense where they go. The farthest to the right has to be the largest ratio. Well, root 3 over 2 is the largest ratio. The least to the right has to be the smallest ratio. Well, 1/2 is the smallest, and root 2 over 2 is in the middle. For the y value, if it's the highest, it has to have the highest y value. If it's the lowest, it has to have the lowest y value. So any quadrant, if it's the farthest from the y-axis, if it's the farthest over, the x is root 3 over 2, either positive or negative. If it's the farthest down, the y value is root 3 over 2. If it's the least down or the least over, the x value is 1/2. So let's see if we can use that to answer this question. So cotangent of 4 pi over 3. And we want an exact answer. That means to use the unit circle, don't just type it in your calculator. So at 4 pi over 3, our ordered pair is negative 1/2, negative root 3 over 2. Negative 1/2, negative root 3 over 2. And the ratio for cotangent is x over y. So if we take the x ordinate divided by the y ordinate, since we're dividing by a fraction, we keep, change, flip. So our 2's cancel, our negatives cancel, and we get 1 over root 3, or if we rationalize that, we get root 3 over root 9, which is 3. So root 3 over 3. Just by reading off the unit circle and then using our definition for cotangent based on x, y, and r, then we can get that trig ratio. Now let's do cosine of 5 pi over 4. So 5 pi over 4 is negative root 2 over 2, negative root 2 over 2. That's the ordered pair at 5 pi over 4. Cosine is the x coordinate on the unit circle. So cosine is negative root 2 over 2. Specifically, it's that one, but they're the same. So cosine is negative root 2 over 2 at that angle. Here, they ask us for cosecant of 20. Notice that's not 20 degrees. If it were 20 degrees, it would have a degree symbol on it. If it's not, then that is 20 radians. So that's not a standard angle. If we look at our unit circle, that's not one of the angles found on our unit circle. So we have to use our calculator. So how do we use our calculator to evaluate cosecant? Well, we don't have a cosecant button. So if we want to find cosecant of 20 radians, cosecant is the reciprocal of sine. So if we know sine of 20 radians, cosecant 20 will be the reciprocal of that. So 1 divided by that. So on my calculator, I can just type, I can go to radian mode, and I can type sine of 20, and then I have a reciprocal button. And that gives me 1.0954. Usually when we get ratios, we go to 4 decimal places. I could have also done 1 divided by and taken sine of 20 and done it that way. Either way, we would come up with the same thing. So whether we calculate sine of 20 and then take the reciprocal, or do 1 divided and get sine of 20. That's our answer. The last questions come from section 6, and they deal with graphing trig functions. So let's look at some graphs. Let's look at the graph of a basic sine wave, and then we'll later look at the graph of a basic cosine wave. So I think I have some graph paper, but I'll just sketch this out. Let's put pi radians here. So 2 pi would be somewhere around here. Halfway in between here, that would be pi over 2. This would be 3 pi over 2. If one of those spaces is 1 pi over 2, this would be 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2. This would be pi over 4. This would be 1 pi over 4, 2. 3 pi's over 4, 4, 5, 6, 7. And we could also, if we wanted to, we could put marks for power 6 and power 3. So I'm going to put those in. Don't have to have those. But in every quadrant between every 90 degrees or every pi over 2, we have 3 special angles in there. So 3 tick marks. So if we think about our unit circle, remember that on the unit circle, the x value is cosine, the y value is sine. So if we're wanting to plot our plot points here, then when we start out in our direction or our angle, if x is 0 degrees, or we're going to do this in radians, if our angle is 0 radians, then y is sine of that. So our input is our angle. Our answer is sine of 0. Well, from the unit circle, sine is the y-coordinate. So the y-coordinate, when we're in a direction of 0, that y-coordinate is also 0. But when we rotate around, let's say to pi over 4, when our angle is pi over 4, sine of pi over 4 is the y-coordinate at pi over 4, which is root 2 over 2. We could get that as a decimal. Root 2 over 2 is about 0.71. So if 0.5 is here, it's more than 0.5. Not quite 3/4 of the way up. When we get to pi over 2, if we put pi over 2 in as our angle, sine of pi over 2, sine when we're straight up, the y-coordinate straight up is 1. Now, if we plotted the values of sine at these other angles, then sine of 30 degrees or pi over 6 is 1/2. Sine of 60 degrees or pi over 3 is root 3 over 2, which is about 0.86. So we have a graph that looks something like this. It's not a straight line, it's more of a curve. So what we plotted is the values for sine at each angle. So if we follow our unit circle around and follow the values of sine, then the values of sine, which are the y values, they start going down until we get to pi. Our y value is 0. So when we get to pi, our y value is 0. Sine at pi is 0. Sine at 3 pi over 4, it's up, so it's positive root 2 over 2, which was what we said is about 0.71. So we're going to be kind of like this. As we continue around, we're making our way towards 3 pi over 2. When we get to 3 pi over 2, sine at 3 pi over 2 is -1, because again, sine is the y value. So 3 pi over 2, we're down here. So we could plot the rest of those points, but we're going to get that same type of curve. And then when we go through the last quadrant, when we get back to 2 pi, our y, excuse me, our y value is back to 0. So that's our sine wave through one period. Going from 0 to 2 pi, that's what the sine wave looks like. The sine wave just follows the y value around the unit circle. So the y value starts as a y value of 0. It gets bigger and bigger until it peaks out at a height of 1. Then it gets smaller until it gets to 0. Then it keeps getting smaller until we get to -1. And then our y value starts getting bigger and bigger until we get back to 0. So that's a sine wave. And if we continued past 2 pi, then we would be going through the same ordered pairs. Our angles would just be larger. So if we continued on around, we would continue the same pattern. Our y values would be going up until it got to the top, then it would come down until it got to -1, then it would go back up. So we have a wave. and this is a sine wave. It takes 2 pi to repeat, so the period is 2 pi. The amplitude is the distance from the middle to the top, so we have an amplitude of 1. In this case, the middle we call equilibrium. If we imagine our wave being at rest, not going up or down any, then it would be here. And then we could think of everything as a positive or a negative rise or up or down from that middle point, that middle height. So we're considering that middle equilibrium. So that's a sine wave, cosine wave. So if we plot our angles in the x direction and in the y direction, if we plot the answer to cosine of our angle, we're going to do the same thing. Pi, 2 pi, this will be pi over 2, 3 pi over 2, and then I'm just going to do the pi over 4s. Look at those. So that's pi over 4. All right. So if we follow our unit circle, cosine is the x-coordinate on the unit circle. So when we're in a direction of 0, when our angle is 0, the x-coordinate there, cosine, is 1. As we rotate around, when we get to pi over 2, cosine of pi over 2 is 0 because the x value there is 0. As we rotate around farther, when we get to pi, cosine of pi is the x-coordinate there, which is -1. As we rotate farther to 3 pi over 2, cosine at 3 pi over 2 is 0 because the x value here is 0. And when we get back to here, the x value is back to 1. So our cosine wave looks like this. And if we continued around the unit circle, then we would repeat that same motion. We keep repeating that same motion for whatever our domain is. Here, we go through a complete cycle from 0 to 2 pi. So our period is 2 pi. Once we get back here, we're going to start repeating the same thing. Of our standard cosine wave is 1, because the distance from the peak to equilibrium or the trough to equilibrium, that distance is 1 in either case. So period and amplitude. So most of our sine and cosine waves are not just going to be just y equals sine or y equals cosine. So the generic form is y equals sine a sine bx minus c plus d. A is the amplitude. B helps us get the period. 2 pi over b is the period. C helps us get the horizontal shift. C over b tells us the horizontal shift. Often you'll see that in absolute values because the period is a positive amount. For the horizontal shift, I always say it goes opposite of the sign. So if this is a minus, we actually shift it to the right. If it's a plus, we shift it to the left. But notice C is added or subtracted directly to the X term. D comes after we have taken sign. So that D is not added directly to the X, it's added to the answer of that. So D creates a vertical shift. If it's positive, it's up. If it's negative, it's down. So for hours, our A is 1. So we have an amplitude of 1. Our B is the coefficient of X. Our B is 1, which means the period is 2 pi over 1, or just 2 pi. That's how long it takes to repeat. C is 0. There's no number added or subtracted directly to the X. If that 9 was added directly to the X, that would be a parenthesis. Since there's not, then that 9 is a function. So C is 0. So that means our horizontal shift is 0 over 1, or just 0. So it's not shifted horizontally at all. D is 9, so that means our vertical shift is up 9. So if we graph this, we would have a standard sine wave that has a period of 2 pi. It has an amplitude of 1. It's not shifted over any, it's just shifted up 9 units. So if we sketch, and there's some graph paper in Canvas to help you with this. Up, I'm going to come right here and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And I'm just going to say there's pi, and there's 2 pi. That would make that 3 pi and 4 pi. And I'm going to do that so that we can graph 2 cycles of our period. So remember a sine wave. What does a sine wave look like? It starts at equilibrium. It goes up, down, down, and back up. So if we were to draw a standard sine wave, I like to draw the correct period and the correct amplitude first, and then shift. So let's do the period and amplitude, and then we'll shift from there. So our period is 2 pi. So if we start here, it ends when it gets to 2 pi. Notice on the regular sine wave that we're at equilibrium at the beginning and the end. We're also at equilibrium halfway between. So if we're going to end when we get to 2 pi, we're at equilibrium in the middle also. We're at a peak between the first 2 equilibriums, and our amplitude is 1, so our peak is going to be up 1. We're at a trough between the last 2 equilibriums. So between the last 2 equilibriums, we're going to be down 1. So using this scale, our first period of our sine wave looks like that. Up 1, down 1, between 0 and 2 pi. Now we need to apply our shifts. So our vertical shift is up 9. Our horizontal shift is 0. So we don't go over any, we just move the whole thing up 9 units. So every point we're going to move up 9. So this point goes up 1, 2, 3, 4, 5, 6, 7, 8, 9. This point goes up 1, 2, 3, 4, 5, 6, 7, 8, 9. This one goes up 9. This one goes up 9. The last one goes up 9. So we have the exact same shape. It's just up 9 units. If it would be beneficial, you could even draw equilibrium through that. the equilibrium line was originally the x-axis, that's been moved up there. And one reason they're doing that is it does help us as we copy. So if we want to draw another period, if our period is 2 pi, if this one ended at 2 pi, 2 pi later would get us to 4 pi. So we're going to be at equilibrium when the next one ends. Halfway in between, we're at equilibrium. Between these two equilibriums, we're at a peak. Oops. Between the last two equilibriums, we're at a trough. So our next period would look like that. So once we got it the right size and shifted it into the right place, then we can copy it as many times as we need. All right, let's look at this one. The same rule applies for cosine. A is the coefficient, so it doesn't, in the form we had it written in last time, the number added or subtracted was on the end, but it could be on the end or out front as long as it's a constant term. B is the coefficient of x. C is the number added or subtracted from the x term, and I'm just going to write the number. We'll talk about the direction later. D is the vertical shift, and in this case D is 2. So we have an amplitude of 7, a vertical shift of 2, and it's up because it's added. B helps us determine the period. The period is 2 pi over B. So that means we have a period of 2. And our horizontal shift is C divided by B. C divided by B. So we go 8 over pi units, opposite of that sign. So that's a minus, so we go to the right that far. This one doesn't ask us to graph it, but we could. We would just graph it to have a period that repeats every 2 units. So if this was 1 and this is 2, then cosine, think about our basic cosine wave. It starts at a peak, it goes down, down to a trough, back up to a peak. So we have an amplitude of 7, so it would go up to 7. By the time we got to the end, it would be back to a peak. Halfway between 2 peaks, we would be at a trough, so halfway between where it starts and where it stops would be at 1, we would be down at a trough. Halfway between a peak and a trough, we're at equilibrium. Halfway between a peak and a trough, we're at equilibrium. So our cosine wave will look like this. So that is the correct period and the correct amplitude. Notice that's not 2 pi, that's just 2 units. So then we would have to create a vertical shift. We would have to move it up 2 units, and then we would move it to the right, 8 over pi. 8 over pi, if we take out our calculator and do 8 divided by pi, that's basically 2.5 units to the right. So we would move every point up 2 and to the right 2.5 units. All right, let's take a look at this one. So A, that's the coefficient of phi, which is -1. B is the coefficient of x. C is the number added or subtracted to that. D is on the end by itself. That's the constant term. So our amplitude is -1. Our vertical shift is 1/5 of a unit. not a very big vertical shift. Our period is 2 pi over b. Well, dividing by 1/3 is like multiplying by 3 over 1, so our period is 6 pi. C tells us our horizontal shift. Our horizontal shift is C divided by B. Well, if we take pi over 3 and divide by 3 over 1, we would multiply by, I'm sorry, if we divide by 1/3, we're multiplying by 3 over 1, so we would get pi units, and that's to the right. Our vertical shift was up, because that's a positive. So that's our amplitude, our period, our phase shift. The phase shift is the horizontal shift. On this one, they want us to recognize the graph. So I would like for you to be able to graph this from scratch. So A is 1, B is 1, C is pi over 6, D is 4. So our amplitude is 1. Our vertical shift is down 4. Our period is 2 pi over b, so 2 pi. And our horizontal shift is c divided by b. Well, pi over 6 divided by 1 is pi over 6, and that's going to be to the right, because we go opposite of that sign. Vertical shift, we go the same as the sign. So we have our amplitude, we have our period, our vertical shift, and our horizontal shift. So let's see. I've got some graph here. Let's just use this. So let's do our period and amplitude first. So our period is 2 pi, our amplitude is 1, and cosine. Remember that cosine starts at a peak, goes down, back to a peak. Since our amplitude is 1 and our vertical shift is 4, let's just call 1 block 1 unit. So if we start at a peak to begin with, if our period is 2 pi, that's when our next peak would occur. From one peak to the next peak, that's our period. Halfway between two peaks is always a trough. So if this is equilibrium, then our trough would be down 1. Between a peak and a trough is equilibrium. Between a peak and a trough is equilibrium. So our first cosine wave looks like this. That's before we do the shifts. Now our vertical shift is down 4, our horizontal shift is to the right, pi over 6. So if this is pi, this would be pi over 2, this would be pi over 4, so pi over 6 would be about this far. So we're going to move each point to the right, not quite a full box, and then we're going to move each down 4. Because our horizontal shift is to the right, pi over 6, our vertical shift is down 4. So I'm going to take the first point, I'm going to move it to the right, not quite a full unit, and then down 1, 2, 3, 4. So that'll get us there. Then I'm going to go to the next point, and I'm going to move it almost a block over, and then go down 1, 2, 3, 4. And I'm going to do the same thing with each point. So the next point over here and then down 1, 2, 3, 4. And then the next one over and then 1, 2, 3, 4. And the last one, over and down, 1, 2, 3, 4. So that gets us right there. So we have a full period between here and here. Equilibrium is in the middle, so our amplitude from there to there or there to there is 1. And then we could copy that however many times we need it. Here they give us a graph, and they want us to take the graph and determine the equation in this graph. So we need to know a couple things. We need to know the amplitude, we need to know the period, we need to know the shifts. So the first thing I like to do is figure out where equilibrium is. Well, if this is up 1, and then the peak or the trough is down 5, from 1 to -5, the distance, remember to get distance, we take the difference. 1 minus -5 is 6. So from here to here is 6 units. So halfway between would be 3 units. So 1, 2, 3, there's equilibrium. 1, 2, 3 down, 1, 2, 3 up. So equilibrium is down 2. Equilibrium is down 2. So that means our vertical shift is down 2 units. Well, that narrows us down to either B or C, because A and B are up 2, not down 2. If we're doing a cosine wave, remember cosine starts at a peak when x is 0. Cosine starts at a peak going down. Well, this starts at a peak when x is 0. So it's our first peak is not to the right or to the left. Our first peak is right at x equals 0. So that means that our horizontal shift is none. There is no horizontal shift because the first peak has not been shifted right or left. Our amplitude, remember the amplitude is the distance from equilibrium to the top or to the bottom. So we already said that that distance from equilibrium to a peak or trough is 3 units. So that's A. And then our period is the distance from one peak to the next, or we could say from 2 corresponding points on the wave. So from here to here, that completes one cosine wave. That's from 0 to 2 pi. So one period, it takes 2 pi to go through a complete cycle. Here to here, we've gone through a complete cycle in 2 pi radians, so that's our period. So remember, our vertical shift is D. So our D is -2. Our amplitude is A. So our amplitude is 3. The period is 2 pi over B. We need to know B. Well, if the period is 2 pi, and then to calculate period, we do 2 pi over B. B would just be 1. What under 2 pi would make 2 pi? Or you could isolate B, but regardless, we would get B is 1. Period is 2 pi over B. We know the period from looking at the graph. We can solve that equation to get B. And then the horizontal shift is C divided by B. Well, the horizontal shift is 0. B is 1. So C is 0. So if we write our function, y equals A cosine bx minus c, and then d. So we don't have to put the parentheses because we can drop the 0. The coefficient of x is 1. We don't necessarily have to write that. And then we can put the minus 2 in. So 3 cosine x to minus 2, that would be b. So that's another task that you need to be able to do for the test. Look at a graph and determine the equation of it.